My dear friends, now we start with the numerical formulas and then I'll be solving the unsolved numericals. So to begin with, the numerical formulas of this particular chapter. First one is, when you talk about the rate of a reaction, it is nothing but delta C upon delta T. That means it will be being changed in the concentration, of either the reactants or products with respect to the change in time. So that is delta C upon delta T, or we can also be very clear, and that is delta concentration of R upon delta T minus, or we can say plus delta P upon delta T, where R stands for reactants and P stands for products. Alright, next one is, we have the rate of a reaction R is equal to, when we talk about the value of K, the rate constant, so R is equal to K into the concentration of the reactants. This is the rate law equation. ये कौन सा है? Rate law equation है. Next part is K is equal to 2.303 upon T into log of initial concentration upon the concentration of the reactant at a particular time interval T. That can also be given as 2.303 upon T into log of A upon A minus X, जहाँ पर A is the initial concentration and A minus of X is the concentration at time equal to T. So X is the amount of the reactant which is being converted into products. Yani amount of the reactant undergoing reaction. So that is X. तो फिर A minus of X क्या होगा? The concentration of the reactant remaining at time equal to T. तो ये हम लोग लिख सकते हैं, और ये याद रखिएगा दोस्तों, this is for first order reaction. उसी प्रकार से T half for the first order reaction is 0.693 upon K, जहाँ पर K is a rate constant. Next one is K is equal to A0 minus of AT upon T, and this is going to be for zero order reaction. A0 मतलब initial concentration minus the concentration of the reactant at a particular time interval divided by what? The time. So that is A0 minus AT upon T, that is going to give you the rate constant for zero order reaction. Similarly, T half is equal to concentration, initial concentration divided by 2K, where K is the reaction quotient, or we can also call it as rate constant, and that is the half-life value for this, or half-time value, and it's for zero order reaction. Remember that. This is for zero order reaction. Next part now, and that is we go into, and that is with respect to the Arrhenius equation, where K is equal to A into e raised to minus of E upon RT. So that means we can also say that log of K is equal to minus of EA upon 2.303 RT plus log of A. Where A is a frequency factor. उससे हमें पता चलता है कि what is the frequency of collisions taking place, और या तो उसको बोला जाता है pre-exponential factor. E is the energy of activation, R is the gas constant, and T is the temperature. Similarly, we can also say that log of K2 upon K1, is equal to EA upon 2.303 R, T2 minus of T1 upon T1 into T2. Now here we are going for two different temperatures, T1 as well as T2. लेकिन यहाँ पे condition याद रखना दोस्तों कि T2 is going to be greater than that of what? T1. तो T2 मतलब higher temperature पे जो rate constant होगा that is K2, और lower temperature पे जो rate constant होगा that is K1. So that is K2 and K1 corresponding to the temperatures T2 and T1. ये आपको बताइए, that is it is energy of activation and R is the gas constant. And then T2 minus T1 इसलिए करना है क्योंकि मैंने आपको पहले ही बोल दिया कि T2 is going to be greater than that of what? T1. तो उस हिसाब से आपको सिलेक्ट करना है. Okay, next one is the fraction of the number of molecules having a particular energy which is either equal to the activation energy or greater than the activation energy. So that what will happen is, in spite of the collisions taking place, okay, then those collisions gets converted into effective collisions. Okay, because collisions दो प्रकार का होता है, effective as well as ineffective. Effective collision वो होता है कि जो collision होने के बाद reactants products में convert होता है, और उसके लिए जो बहुत अहम कंडीशन है वो है that reactant molecules should have an energy, kinetic energy at least equal or greater than that of activation energy. So the fraction of the molecules having that particular kinetic energy, that is F, is equal to e raised to minus of EA upon RT. Okay, ये हमें इक्वेशन मिलता है. So these are the various equations now. First is we have a rate of reaction, then simple rate law equation which only depends upon the concentration of the reactants. मैंने ये first order reaction के लिए कुछ बताया expressions आपको. This is also for first order reaction. This is for zero order reaction. Okay, this also is for a zero order reaction, that is for half time. Okay, this is also called as a Arrhenius equation, which also tells you about the rate of the reaction with temperature, how they are related with each other. Okay, then accordingly we are using the log values and we are finding it out. Two different temperatures, if you want to find out the activation energy, that is what we can do. And the fraction of the molecules, reactant molecules having the sufficient kinetic energy, okay, that can be given by this particular expression. Okay, so my dear friends, these are some of the important formulas, okay, which you will be coming across while solving the numericals of this particular chapter of chemical kinetics, and I am very sure you have understood these formulas. Okay, my dear friends, now once we have done with the formulas, we now go into the solving of the unsolved numericals. So under question number 4, if you can see, solve the following. Okay, so under that we are going to start with the first one, और वो है, in a first order reaction, the concentration of the reactant decreases from 20 millimoles per dm cube to 8 millimoles per dm cube in 38 minutes. Then what is the half-life of the reaction? It's a first order reaction. तो मैंने आपको तो बोला था दोस्तों कि फार्मूला है K is equal to 2.303 upon T into log of A upon A minus of X. So that is equal to 2.303 upon T. So T is nothing but 38 minutes into log of A upon A minus of X. So this is 20 and then we have 8. Okay, A minus of X. 8 is nothing but the concentration which is remaining. Alright, so that will be equal to 2.303 upon 38 into log of 2.5. Okay, so that is equal to 0.0241. Okay, this is what we get. And this is K for the first order reaction. So the units, please keep in mind. A is a concentration, A minus of X is a concentration, so concentration gets cancelled. T is in the denominator, 2.303 is just a number. So उसको ऊपर लेके जाएंगे तो टाइम इनवर्स हो जाएगा. So यहाँ पे टाइम किस में दिया है? मिनट्स में. So this is going to become minute inverse. Okay, so this is as far as K is concerned. अभी हमें फाइंड आउट करना है T half. T half is equal to 0.693 upon K. So that is equal to 0.693 upon 0.0241. So that is equal to nothing but 28.75. अब ये K है, इसका यूनिट मिनट इनवर्स है, वो डिनोमिनेटर में तो ऊपर चला जाएगा तो मिनट्स हो जाएगा. So it is going to be in minutes. So 28.75 minutes. This is the final answer. यानी पहले K find out करो और K find out करने के बाद you calculate T half. Okay, this is the way we find out the half-life of the first order reaction. I hope आपको ये first numerical अच्छी तरीके से समझ में आ गया होगा. Now my dear friends, we go into the second one, and that is the half-life of the first order reaction is 1.7 hours. Okay, hours. How long will it take for 20% of the reactant to react? ठीक है, ये है. तो पहले क्या करते हैं, फॉर्मूला आपको बताया that is T half is equal to 0.693 upon K. So therefore what we do is K will be equal to 0.693 upon T half. So that is equal to 0.693 upon 1.7. So that means it is going to give you 0.4076. Okay, this is K, and the units is going to be what? R inverse. ये हमें K मिल गया. Okay, अभी next formula, क्योंकि हमें find out करना है क्या for 20% reaction के लिए how much is the time required. So K will be equal to 2.303 upon T into log of A upon A minus of X. How long will it take for 20% of the reactant to react? Okay, यानी इसका मतलब क्या है कि initial अगर A is 100, okay, A कितना है 100, तो अभी reaction कितना हो रहा है? Take for 20% of the reactant to react, यानी X is equal to 20. So therefore A minus of X will be 100 minus 20 and that is equal to 80. तो ये फिर इधर सब्स्टिट्यूट करना है. सो K का वैल्यू तो मुझे मालूम है, तो व्हाट वी डू इज पहले T को इधर ले लेता हूँ मैं. T is equal to 2.303 upon K into log of A upon A minus of X. So that is equal to 2.303 upon 0.4076 into log of A is 100, initial concentration है, divided by the concentration which is remaining, and remaining is 80. So that is equal to 2.303 upon 0.4076 into log of 1.25. Because 100 upon 80 is going to be what? Nothing but 1.25. So that is going to give me the final answer as 0.547. Okay, ये मुझे मिलेगा, लेकिन ये कौन सा मिलेगा मुझे T in terms of what? Hours. Okay, this is going to be in hours. So please don't make a mess around as far as the units are concerned. Okay, यहाँ पर hours में दिया तो यहाँ पर आपको hours ही लिखना है. You cannot get it converted into seconds or minutes or something like that. हाँ, अगर आपको convert करना ही है तो you can do it. Okay, यानी 0.547 hours को if you want to convert it, then it is going to give you what? 32.85 minutes. ये दे सकता है. Okay, क्योंकि आपको तो मालूम है what is the conversion is. Okay, 1 hour is 60 minutes. तो फिर 0.547 will be how much? Okay, 0.5 है तो it will be 30 minutes. Common sense है. आधा घंटा मतलब 30 मिनट है. ये 0.54 है यानी 30 मिनट से थोड़ा ज़्यादा. So it is 32.85 minutes. लेकिन दोस्तों, let me be very clear in this. How long will it take for 20% of the reactant to react? Full stop है. ऐसा नहीं बोला है कि in minutes या in hours or anything like that. तो जब specify नहीं किया तो you can stop over here, provided you write down the value very well and the units. Okay? ये तो optional है. Okay? ये आपको जो convert करना है minutes में वो optional है. हाँ, अगर ऐसा लिखा होता कि in dash तो फिर आप बराबर है, तो फिर आपको मेंशन करना जरूरी है. लेकिन यहाँ पर ऐसा कुछ नहीं. You can just stop over here as well. But I hope you understood this. दो पार्ट है कैलकुलेशन का. पहला पार्ट है कि हमें T हाफ ऑलरेडी मालूम है तो उससे K फाइंड आउट करो, और एक बार K पता चला तो फिर हम T फाइंड आउट करेंगे. और ये 20% वाला चक्कर याद रखिएगा कि परसेंटेज है, सो वी विल कीप इट एज 100. सो अगर A इज इक्वल टू 100, सो द A माइनस ऑफ X विल बिकम 80, क्योंकि 20% रिएक्ट होने वाला है. तो 100 में से अगर 20 रिएक्ट हुआ तो बचेगा कितना? 80. सो ये वाला पार्ट. तो बस इतना 2-3 पॉइंट्स आपको याद रखना, अदरवाइज दिस न्यूमेरिकल इज वेरी इजी. आई होप आप लोगों को ये अच्छी तरह से समझ में आ गया होगा. Okay, my dear friends, we now go into the number 3 problem, and that is the energy of activation for a first order reaction. Okay, and that is 104 kilojoules per mole. The rate constant at 25 degrees Celsius is this much. What is the rate constant at 30 degrees Celsius? And R value is given as 8.314. Alright, so now we start off with the important one, T1 and T2. These are the ones which are being given. Alright, so now what we have is T2 is always greater than T1. ये मैंने आपको पहले भी बताया. So T2 is 30 degrees Celsius, T1 is 25 degrees Celsius, which will be now called as 298 Kelvin, and this will be called as 303 Kelvin. ठीक है, क्योंकि वो केल्विन में कन्वर्ट करना है. अब इसका कॉरस्पॉन्डिंग K1 और इसका कॉरस्पॉन्डिंग K2 वैल्यूज. Okay, now the rate constant at 24 degrees Celsius is how much? 3.7 into 10 raised to minus of 5 second inverse. टाइम इनवर्स है तो इट इज अ फर्स्ट ऑर्डर रिएक्शन. वो भी एक तरीका है पता करने का कि वेदर द रिएक्शन इज फर्स्ट ऑर्डर और सेकेंड ऑर्डर. फिर K2 इज नथिंग बट उसका वैल्यू हमें फाइंड आउट करने का है. सो व्हाट इज द रेट कांस्टेंट एट दिस एंड R का वैल्यू दिया हुआ है. नाउ अगर आपको याद है द फार्मूला इज log of K2 upon K1 okay is equal to EA 2.303 R bracket T2 minus of T1 upon T1 T2. ठीक है, if you remember you had this particular formula. Now EA energy of activation is 104 kilojoules. तो उसको जूल्स में कन्वर्ट करने के लिए we are going to use 10⁻³ क्यों ऐसा? बिकॉज हमें R भी यूज करने का है. R इज फॉर इन जूल्स. यानी ये सब बातें याद रखो. द यूनिट्स मस्ट बी मैचिंग. ठीक है, सो इसलिए इस किलो जूल्स को जूल्स में कन्वर्ट करने के लिए 10⁻³ से मल्टीप्लाई किया हमने, डिवाइडेड बाय 2.303 इंटू 8.314 T2 माइनस T1 मतलब इट इज 303 माइनस 298 डिवाइडेड बाय 303 into 298. So that is equal to 104,000 upon 2.303 into 8.314 into 5 upon 303 into 298. दोस्तों एक बात याद रखिएगा, डिफरेंस इन टेम्परेचर चाहे वो डिग्री सेल्सियस हो या फिर केल्विन हो कोई मायने नहीं है. ओके, सो T2 माइनस T1 अगर मैंने वो उसको केल्विन में कन्वर्ट नहीं भी किया था तो भी उसका आंसर 5 आता था. लेकिन गड़बड़ किधर होता है? डिनोमिनेटर में, बिकॉज डिनोमिनेटर इज T1 इंटू T2. ओके, तो अगर आपने ऐसा गलती से कर दिया कि इट इज 300 ओके एंड 295 सॉरी 30 एंड 25 एंड इट गिव्स यू 750, पूरा गड़बड़ हो जाएगा. यानी ये बात आप जरा ध्यान में रखिएगा कि 30 और 25 को पहले इसमें कन्वर्ट कर दीजिए इन टर्म्स ऑफ केल्विन. So now this log of K2 upon K1, when you solve this entire part, okay, it's a simple multiplication and division, you get the answer as 0.3. Log of K2 upon K1 is equal to what? 0.3. ठीक है, अभी taking log on both the sides, तो यानी divided by log, तो divide by log on both the sides, what we get is K2 upon K1. इनके log डिवाइडेड बाय log कैंसिल हो जाएगा. दैट इज इक्वल टू, इधर तो log है ही नहीं तो डिवाइड बाय log मतलब एंटी log हो जाएगा. सो दैट इज इक्वल टू एंटी log ऑफ 0.3. सो K2 अपॉन K1 इज इक्वल टू एंटी log ऑफ 0.3 इज 2. ओके, एंटी log ऑफ 0.3 इज व्हाट? 2. सो K2 अपॉन K1 इज इक्वल टू 2. सो देयरफॉर K2 विल बी इक्वल टू 2 इंटू K1. सो दैट इज इक्वल टू 2 इंटू K1 का वैल्यू दिया हुआ है, दैट इज 3.7 into 10 raised to minus of 5. So that is equal to 3.7 into 2 gives you 7.4 into 10 raised to minus 5 और यूनिट वही रहेगा जो K1 का था and that is second inverse. Okay, K1 का second inverse है तो K2 also will be second inverse. Okay, so it is 7.4 into 10 raised to minus 5. Okay, so K2 is going to be what? Double. Okay, rate constant double हो जाता है when the temperature increases by 5 degrees Celsius. That can be the conclusion that can be drawn as far as this particular observation is concerned. Alright, तो वापस से बोल देता हूँ, दो टेम्परेचर वाला जो फार्मूला है that is log of K2 upon K1 is equal to EA upon 2.303 R into T2 minus of T1 upon T1 into T2. This is what the formula that you are going to use. Okay, और ये फार्मूला के बेसिस पे हम कोई भी टर्म फाइंड आउट कर सकते हैं provided all the other terms are known. यानी ये न्यूमेरिकल में भी ऐसा ही है. ओके, K2 को छोड़ के हमारे पास सब वैल्यूज था तो हम लोग ने K2 आसानी से पता कर लिया. ओके, सो आई होप यू हैव अंडरस्टूड दिस वेरी क्लियरली. Hence we go into the numerical number 4 and that is what is the energy of activation of a reaction whose rate constant doubles when the temperature changes from 303 Kelvin to 313 Kelvin. ठीक है, that is what it is. So we begin with, first of all, the formula that I guess you will be knowing very well. Log of K2 upon K1 is equal to EA 2.303 R into T2 minus of T1 upon T1 T2. ठीक है, ये फॉर्मूला है. अब as usual T2 is the higher value, so T2 will be equal to 313 Kelvin and T1 obviously will be 303 Kelvin. Okay, अब देखिए क्या बोला है. What is the energy of activation of a reaction whose rate constant doubles, okay, when the temperature changes from so and so. यानी इसका मतलब ये हो जाता है कि यहाँ पे जो रेट कांस्टेंट है दैट इज से K1, यहाँ पे जो रेट कांस्टेंट है वो है K2, and this at temperature of 313 Kelvin it should get double, so K2 should become equal to what? 2K1. समझ में आया? डबल हो जाना चाहिए वो कितने 10 डिग्री सेल्सियस केल्विन बढ़ने के बाद. ओके, तो अगर T1 पे K1 है तो T2 पे क्या हो जाएगा, वो 2 of K1 हो जाएगा. तो ये जो एक्सप्रेशन है वो इधर डाल दीजिए, बाकी का तो फिर बहुत सिंपल है. सो log of K2, सो K2 की जगह पर क्या लिखेंगे हम लोग, 2K1 upon K1. Okay, that is equal to EA, that is what has to be determined, divided by 2.303 into 8.314 multiplied by T2 is nothing but it is 313 minus 303 and divided by 313 into 303. This is going to give you log of 2, that is equal to EA upon 2.303 into 8.314 into 10 into 313 into 303. Okay, now log of 2 का value है 0.3010, so that is equal to EA into 10 divided by 2.303 into 8.314 into 313 into 303. So therefore we have energy of activation equal to, this entire part goes on this side, so multiplication हो जाएगा. This is the simple algebraic operation we are performing into 8.314 into 313 into 303 divided by 10. Okay, so that is going to give you 546584.63. ओके, ये बड़ा वैल्यू इतना मिलेगा एनर्जी ऑफ एक्टिवेशन, और वो किस में रहेगा, वो जूल्स पर मोल में रहेगा. अगर मुझे उसको किलो जूल्स में कन्वर्ट करने का, सी वंस अगेन आई टेल यू वेरी वेल, अगर आप लोग ने ये सही तरीके से वैल्यू लिखा और यूनिट लिखा है, सो यू विल बी गेटिंग फुल मार्क्स. क्योंकि यहाँ पर ऐसा कुछ भी मेंशन नहीं किया दैट यू नीड टू कैलकुलेट द एनर्जी ऑफ एक्टिवेशन इन दिस पर्टिकुलर यूनिट, सो योर आंसर कैन स्टॉप ओवर हियर एज वेल. ओके, ये ऑप्शनल है अगर इसको किलो जूल्स में कन्वर्ट करना है, ताकि कि आपको कन्वर्जन्स काफ़ी इजी हो जाएगा. ओके, ये कन्वर्जन्स का प्रैक्टिस हो जाएगा, इसके लिए मैं आपको ये बता रहा हूँ. तो जूल्स को किलो जूल्स में कन्वर्ट करने का है तो ये टू डिवाइडेड बाय 1000, किलो जूल्स को जूल्स में कन्वर्ट करने का है तो मल्टीप्लाई बाय 1000. सो यू डिवाइड दिस बाय 1000, सो 3 decimals to the left, so that is going to give you 546.584. After the decimal 3 digits is enough, 6, it is going to give you kilojoules per mole. So either you put it in joules per mole or you put it in kilojoules per mole, doesn't make much difference. लेकिन यहाँ पर ये इतना याद रखिएगा बस. यहाँ पे the most important point is this, कि टेम्परेचर 10 केल्विन बढ़ने के बाद ओके डबल हो जाता है रेट ऑफ द रिएक्शन. यानी अगर लो टेम्परेचर पे जो इनिशियल टेम्परेचर, लेट अस कंसीडर दिस एज इनिशियल टेम्परेचर, दिस इज फाइनल टेम्परेचर, तो इनिशियल टेम्परेचर पे अगर रेट कांस्टेंट K1 है तो फाइनल टेम्परेचर विल बी व्हाट, 2K1. ओके, रेट कांस्टेंट इज 2K1. बस दैट्स इट. तो ये एक बार आपको समझ में आया, फिर तो मैंने सिंपल अलजेब्रिक ऑपरेशन परफॉर्म किया एंड वी गॉट द फाइनल आंसर. आई होप यू गाइस हैव अंडरस्टूड दिस एब्सोल्युटली वेल. Alright, we are going to the next problem, and that is about the rate constant of a reaction at 500 degrees Celsius is 1.6 into 10 raised to 3. Okay, molar inverse and second inverse. What is the frequency factor of the reaction if its activation energy is going to be 56 kilojoules per mole? Okay, that is what we need to find out. Alright, so we'll begin with, first of all is the rate constant K is equal to 1.6 into 10 raised to 3, that is equal to 1600. Okay, that is what we get after multiplying by 10 raised to 3. Now when we go into the formula says log of K is equal to log of A minus of EA upon 2.303 RT. Okay, 2.303 RT. Now we bring this on this side. So log A will be equal to log of K plus EA upon 2.303 RT. So that is equal to log of K, log of 1600 plus EA, energy of activation, कितना दिया है 56 kilojoules per mole, इतना दिया है. तो फिर kilojoules को joules में convert करने का तो आपको पता अच्छी तरीके से, it is multiplied by 10⁻³ divided by 2.303 into 8.314 into the temperature. Now temperature is what? 500 degrees Celsius है. अभी temperature अगर 500 degrees Celsius है दोस्तों, so that is equal to what? 773 Kelvin. तो 773 Kelvin. So just keep it as, यहाँ पे units लिखने की जरूरत नहीं. So log of 1600 is, उसका characteristic 3 आएगा. So 3.2041 plus 56,000 divided by, ना ये पूरा 14,800.74 ये आएगा आंसर. So that is equal to 3.2041 plus 3.7835 आएगा इसका आंसर. Okay, this entire answer will be 3.7835. So that is equal to, ये दोनों ऐड करोगे तो आपको मिलेगा 6.9876. ये किसका वैल्यू मिला आपको? log A का वैल्यू मिला 6.9876. ओके, अब क्या करो? both the sides divide by log, तो मुझे मिलेगा A is equal to anti log of 6.9876. ओके, इसका एंटी लॉग लेने का. Okay, divide both the sides by log, so that's why we get that way. So therefore what we get is 9.721 into 10⁻⁶, and the units will be the same, and that is S. Okay, तो इस तरीके से हमें आंसर मिलेगा. ये 6 तो of course characteristic है, so that will be 10⁻⁴ of the characteristic, and 0.987 इसका एंटी लॉग. Okay, it's going to give you 9721. तो फर्स्ट डेसिमल के बाद, ओके, फर्स्ट डिजिट के बाद एक डेसिमल पॉइंट डाल दीजिएगा एंड देन मल्टीप्लाई बाय 10⁻⁴ ऑफ द कैरेक्टरिस्टिक. तो ये आपको फाइनल आंसर मिल गया, दैट इज 9.721 into 10⁻⁶. सो वंस अगेन आई रिपीट, हाउ वी नीड टू कैरी आउट दिस. के का वैल्यू दिया, रेट कांस्टेंट का वैल्यू दिया, एंड दैट इज गोइंग टू बी 1.6 into 10⁻�3. सो 1.6 into 10⁻�3 को पहले हम लोगों ने उसको कन्वर्ट कर दिया, तो वी गेट, मतलब 10 का पावर हटा दिया तो वी गेट 1600. उसके बाद what we get is log of K is equal to log A minus of E upon 2.303 RT. Alright, so as a result of which हमारे पास E का value है, we got all the other values also, R as well as T. Please don't forget 500 degrees Celsius, don't write it as it is. उसको convert करो in terms of Kelvin, so that is 773 Kelvin, and you get this particular answer. And then 3.2041 is what is the log of 1600 is. You calculate this entire one, you get is 3.7835. So the total, when you add both of them, okay, what you get is 6.9876. Or if you scanty karo, you get this answer as 9.721 into 10⁻⁶. I hope you have understood this very well. Alright, my dear friends, we now go into the number 6 numerical. Show that the time required for 99.9% completion of the first order reaction is 3 times the time required for 90% completion. Okay, ये हमें प्रूव करना है. ओके, कि 99.9% कंप्लीशन का फर्स्ट ऑर्डर रिएक्शन है वो 3 गुना ज़्यादा है एज कंपेयर टू द टाइम रिक्वायर्ड फॉर 90% कंप्लीशन. ओके, सो द सॉल्यूशन इज नॉट सो डिफिकल्ट. आई विल जस्ट एक्सप्लेन हाउ इट इज. फॉर्मूला आपको मालूम है, एंड दैट इज K इज इक्वल टू 2.303 अपॉन D इंटू लॉग ऑफ A अपॉन A माइनस ऑफ X. अभी फर्स्ट केस कंसिडर करेंगे हम लोग. फर्स्ट केस में see, it is in percentage, so A is equal to 100. Okay, now 99.9% is completed, so X is 99.9. So therefore A minus of X will be equal to 100 minus 99.9, and that is equal to 0.1. Okay, so K will be equal to 2.303 upon T into log of 100 upon 0.1. So K will be equal to 2.303 upon T into log of now 100 divided by 0.1. So that means it gives you 1000. Okay, it will give you what? 1000. Now log of 1000 is 3, so therefore we have K will be equal to 3 into 2.303 upon T, and therefore T will be equal to nothing but 3 into 2.303 upon K. Okay, this is what we get the time for 99.9% completion. Alright, now we go into the next case, and that is, I'll go for the second case now, and that is, in this case also A is equal to 100. Now X will be equal to what? For how much? 90% completion it is. So X is equal to 90. So therefore A minus of X is equal to 100 minus of 90, and that is equal to 10. So we now start with the calculation. Once again the same way, K is equal to 2.303 upon T into log of 100 upon 10. 100 upon 10 is 10. So K is equal to 2.303 upon T into log of 10. Log of 10 is 1. So K is equal to 2.303 upon T, and therefore T is equal to 2.303 upon K. Okay, now have a look at this, my dear friends, and this. Okay, this is the time for 99.9% completion, and this is for 90%. 2.303 upon K, 2.303 upon K, but this is 3 times as that of this, and that is what is written, is 3 times the time required for 90% completion. This is 90% completion, and this is 99.9% completion, and hence proved. Okay, you just compare this and this, and you clearly get the idea. It is 3 times. This is the factor. Okay, that is 3. 2.303 upon K is constant. Okay, so this statement is proved. समझा सब लोग को? Everybody understood this? To the next numerical, and that is, a first order reaction takes 40 minutes for 30% completion. Calculate its half-life. Okay, so first order reaction है, so K is equal to 2.303 upon T into log of A upon A minus of X. जब भी percentage में होता है दोस्तों, so A is considered as 100. Now 30% is completed. Okay, so X is equal to what? 30. So A minus of X will be 100 minus of 30, that is equal to 70. X corresponds to completion. So बचेगा कितना फिर? 100 minus 30 is 70. So that is equal to 2.303 upon T. T is 40 minutes, log of 100 upon 70. So that is equal to 2.303 upon 40 into log of 100 upon 70. So that means it is 1.4285. Alright, so that is equal to, the entire answer that we get is going to be 0.0089. This is the value for K. Okay, हमें rate constant मिल जाता है. अभी हमें क्या फाइंड करना है? हाफ लाइफ. So T half is equal to 0.693 upon K. So that is equal to 0.693 divided by 0.0089. So that is equal to 77.665. Okay, this is what we get. अभी T half का units और K का unit is minute inverse. Time is in minutes. K will be minute inverse. T half will be once again minutes. तो ये अपना फाइनल आंसर आ गया 77.665. यानी इज एज सिंपल एज दैट. पहले K कैलकुलेट करो और फिर T हाफ. सिर्फ इतना याद रखना है, परसेंटेज वाइज यू नीड टू रिमेंबर कि जब भी परसेंटेज में कुछ भी दिया है तो याद रखिएगा A is 100. अभी 30% कंप्लीशन हुआ है. इट्स नॉट 30% लेफ्ट. ओके, 30% रिमेनिंग नहीं है. इट इज 30% इज कंप्लीटेड. ऑलराइट, सो out of 100, 30 is converted into products, so how much remains is 70. तो वो इधर डालना है 70, and then rest of the calculation is very easy. Alright, so that is the way we calculate the half-life for this particular reaction. I hope you have understood this. Alright, my dear friends, we come to the last numerical, okay, which has been included in part of your syllabus, and unsolved numericals I'm talking about. alright, and that is about what fraction of the molecules in a gas at 300 Kelvin collide with an energy equal to the activation energy of 50 kilojoules per mole. Alright, so the formula will be F is equal to E raised to minus of EA upon RT. So therefore we can say log of F is equal to minus of EA upon 2.303 RT. Alright, so that is equal to minus of 50 kilojoules, तो उसको मुझे joules में convert करना है, so I'll make it as 50,000 divided by 2.303 into 8.314 into the temperature is 300 Kelvin. So therefore we have log of F is equal to nothing but minus of 8.7045. Okay, this is what we get. On calculation on the right hand side हमें ये मिलेगा. Okay, अभी divide both the sides by log, तो मुझे मिलेगा F is equal to anti-log of minus of 8.7045. लेकिन दोस्तों ये जो माइनस साइन है वो पूरे टर्म के लिए है, ऑलराइट. लेकिन जब हम लोग लॉग एंटी लॉग निकालते हैं तो यू नो वेरी वेल कि whenever we talk about negativity, so negativity is only with respect to characteristic. मेंटिस हमेशा पॉजिटिव होता है, तो फिर उसको कन्वर्ट करना मुझे, तो मैं कैसे करूँगा. So that is equal to, I'll keep the anti-log as it is. if ये ब्रैकेट वाला देख लीजिए, मैं इसको स्प्लिट करता हूँ as minus 8 minus of 0.7045 और फिर मैं क्या करता हूँ +1 and -1 ऐसा करता हूँ. ओके, ताकि मुझे डेसिमल के बाद जो भी है वो मुझे पॉजिटिव चाहिए, तो इसका मतलब ये हुआ कि मैं ये कंसीडर करूँगा और ये -8 को मैं -1 के साथ कंसीडर करूँगा. सो देयरफॉर F will be equal to anti-log of, now -8 -1 is -9, so it's only 9 is minus, okay, and 1 minus of 0.7045. Okay, this is what we need to do. Okay, 1 minus of 7045, so that means it will be nothing but 2955. Okay, F is equal to anti-log of bar 9.2955. So that is nothing but equal to, the anti-log of 2955 is going to be nothing but 2 into 10 raised to the power of the characteristic, that is -9. So this is what the answer that we get. So the fraction of the molecules which are going to have, and of course with the collision energy, which is an energy equal to this, yani these are all going to result in what? Yes, successive collisions, okay, and it is going to make sure that the reactants are getting converted into what? Yes, products, okay, and thereby the reaction takes place. So that is how much? 2 into 10 raised to minus of 9. Okay, this is the fraction of the molecules which are responsible to make sure that the collisions are effective collisions. ओके, तो ये फार्मूला आपको याद रखना है. मैंने न्यूमेरिकल फॉर्म में ऑलरेडी ये बात बता दिया था आप लोगों को कि F इज इक्वल टू E रेज़ टू माइनस ऑफ EA अपॉन RT. ये फार्मूला यूज करके हमें ये फाइंड आउट करना है. ऑलराइट, सो आई गेस यू हैव अंडरस्टूड दिस एवरीवन. यस, एंड दैट्स इट देन. विद दिस वी हैव कम टू द एंड ऑफ दिस पर्टिकुलर चैप्टर ऑफ केमिकल काइनेटिक्स, जहाँ पर मैंने आपको पहले जितने भी कंसेप्चुअल पार्ट्स थे वो एक्सप्लेन किया. Okay, the different derivations, okay, the different graphs, okay, the different distinguished part, order, molecularity, okay, and so on. और उसके बाद I have given you the numerical formulas, and then I solved the unsolved numericals. So this becomes a complete package, okay, of this particular chapter of chemical kinetics. I'm sure you have all understood this particular chapter and you have enjoyed the journey through this chapter as I enjoy presenting you. Alright, so thank you so very much.